Hello and welcome back to my channel. Today we're going to classify images of handwritten digits from 0 to 9 using pytorch library. So let's get started. On this first cell, we're going to import the pytorch library, which is torch, so import torch. Okay. On the next line, we're going to import the fetch openml class. This fetch openml class will enable us to get or fetch the data from the external server. Okay, on the next line, we're going to import matplotlib.pyplot as PLT so that we can visualize the data. Next is the stratified shuffle split class. This class will help us split our dataset from the xtrain, xvalid, and xtest. Okay, from training set, validation set, and testing set. We can have it from the sklearn model selection library. Next is we need to import this standard scalar class. This standard scalar class will normalize our data. It will have a mean of 0 and a standard deviation of 1 prior to loading it in a training, neural network training. The next one is the library of numpy so that we can save and load the data. And the last one is second to the last one is the GC library, or the garbage collection garbage collector interface. The last one is the dataset and data loader class, which came from the torch.utils data library. The dataset, we will be modifying the dataset, okay, so that we can train it on a mini batch basis. So the data loader will uh, will divide the dataset into mini batches and run the run the algorithm on each individual batch, compute the gradient, and so on and so forth. Okay, so let's run this first cell. On this next cell is that you try to fetch the data from this external server. So you need to remove this comment and save this data to a variable x and y if you haven't had yet the dataset inside your laptop or your computer. So you just need to issue this command, fetch openml, this command here. Okay. On the third cell, you need to save the data inside your computer. So just issue this command numpy.savez. So np.savez, and the name or the location of where you want to save the data. Put in the npc.npc on the data, on the name, and you need to put the variable x into the column name x or the array name x, and put the variable y into the array name y. After you have this data inside your computer, you need to load it up again. This, by the way, this is necessary so that next time you run again this notebook, you don't need to fetch the data outside in an external server. So you just need to fetch it in your computer folder. In this next cell, we need to load the data from where we save it and put it in a variable mnist. Okay. Next, I'm just going to make this command help mnist so that we can see what is inside. So this mnist variable is class npz file. Okay. Its common attributes are files, which is the list of the arrays in there, and allow pickle, which is optional, allowing loading pickle data. Okay, so that's it. That's inside it. Okay. So next is we activate this allow pickle attribute of this mnist true, so that we can load the pickle data. The data that we're interested is this y data, because the y data, previously I saw the y data contains about the numbers, the types of numbers in string format in object. So it's in object format, so I need to enable this allow pickle attribute. Okay, so in this next line we're going to load up the data. As you can see, if we issue mnist that files, it will show what is inside the mnist. It's in this case it shows that there is an x and there's a y. So the x contains the attributes and the y contains the labels. So when we run this one, so it's already inside. Let us look at what is x, what is inside x. X contains about the pixels or the number allocated pixels from each individual number rows. Okay, and then let us see what is the shape of x. So it contains about 70,000 rows of data and 84 columns. So 784 columns contains the pixels, the number which is this designated the pixel numbers. For example, it is black or it is light color in gray. So the number pertaining to that one is stored in these columns, 784 columns all in all. Next, next we're going to delete the mnist dataset to enable us to release some memory. We don't need anymore the mnist dataset because we already have the y and the x variable loaded. Don't So let's see about this one. We check out. So again, we already do this one. The next one is that let's see about the fifth data or the fifth row. The fifth row contains this pixel codes. These pixel codes, okay. This is part of visualizing the data, so we can know what is inside of them. Again, the shape. We already know the shape. It's 70,000 rows. Okay. We need to convert this image or this row into a 28 by 28 pixel. So it means that we need to divide 78 by 784 into 28 by 28. Okay, that is 28 rows by 28 columns. Okay, in order to do that, we just need to reshape this. First, we assign this value in a digit variable. Next, we reshape that 8-digit variable into by 28 by 28, okay, and put that in a variable a image. Prior to that, we need to label the corresponding label of this image. This image x30 has a label stored in y30. Then we show that image. What is that? And we just need to issue this command. See? So the label 3 corresponds to the image 3 here that you can see. The idea is that we need to classify based on this information, this feature image, what is the label of the data. So that is how this this classification will go. By using pytorch, we're going to know what is the label of this image. Next is let us see what are the unique values on these labels. We can see here they are strings, as I've told you before. They are strings from the label 0 up to 9. Okay? And how many are they? So there are 10 different labels. So our task is to predict what are these number images. Okay? So that is all for now. See you in the next video where we're going to data pre-process the data prior to loading it up in a machine learning algorithm. Okay? Bye for now. Thank you for watching.